True astronomy began in the Middle East, from 4000 BC. On towering ziggurats, the Babylonians charted the rising and setting of the sun.
Did they group stars into patterns?
Yes, they understood the cycles of the sky. They learned that the sun, the moon, and the planets moved against the background stars. The planets, as so-called wandering stars, made loops in their paths across the sky. With the sun and the moon, the planets traveled through the same band of the heavens. The Babylonians named it the zodiac. From Taurus the bull, the zodiac passes through 13 constellations. To this day, 12 of them survive in popular astrology, but these mythical figures depict real star patterns. The Chinese kept the longest continuous observations of the sky. From 4,000 years ago, they charted celestial movements with meticulous detail. They made an accurate calendar and star maps like this. The ribbon is the Milky Way. Eclipses of the sun were probably first recorded in China. With the space age came observatories in orbit. Free of atmospheric interference, they could peer in infrared, ultraviolet, and X-rays.
Like the Hubble Space Telescope?
Yes, the Hubble provided a similar clear eye for optical astronomy. Hubble images were stunning, and they were captured by a new breed of highly sensitive electronic detector, the CCD, or charge-coupled device. Chile, South America, a mountaintop in the Andes.
4 telescopes?
Yes. They are linked as one to form the VLT, or Very Large Telescope, the latest in optical astronomy. Despite their ground base, these instruments rival Hubble with image quality, each 8.2-meter mirror providing enormous light grasp.
Have you ever wanted to look back in time? NASA has plans to use the new James Webb Space Telescope to do just that. Because of the time it takes light to travel, the further away an object is, the further back in time we're looking. Light from our sun takes about 8 minutes to reach us here on Earth. So we're really seeing the sun as it was 8 minutes ago. And the light from a star a billion light years away takes a billion years to reach us. By looking at the light from stars formed in the early universe, NASA is about to shed a whole new light on the past.
Under construction is the premier telescope of the next decade. A next-generation space telescope designed to cause yet another giant leap forward in our understanding of the cosmos. It will carry some of the most advanced technologies ever placed on an orbiting observatory.
18 articulated mirror segments, 2.75 times the diameter of Hubble's primary mirror. Microshutters, wavefront sensing and control subsystem, 12 by 18 meter, 5-layer captain-based sunshield.
The Webb Telescope, a revolutionary tool able to study every phase in the history of our universe.
The Webb Telescope.
So the James Webb Space Telescope is it's a fascinating telescope because it's really big. There has never been a mission that is the same as James Webb. Everybody knows Hubble. Hubble became very famous because of all the fascinating pictures that are out there, and James Webb is called the successor of Hubble. But it's going to continue in that line of work somewhat because we still want to understand how the stars are formed, how galaxies are formed. So James Webb is going to look into that, but it's a lot bigger than Hubble. It's
Hubble is the size of a bus, and James Webb fits on a tennis court. So of course it's a lot bigger. The primary mirror is 6.5 meters in diameter, so it's a very big telescope that is going to be really far, far away from us, approximately 1 million miles away from the Earth. So it's just a very big project, a very big telescope, very new.
How do you fit a telescope the size of a tennis court into a rocket that's only as wide as a pickup truck? These are the kinds of questions people at NASA are answering for the James Webb Space Telescope. And the answer they've come up with is to fold it. That's right, the giant mirror and a special sun shield will be tightly compacted and then unfolded when it reaches its orbit. This telescope will study the formation of the first galaxies and how they've changed over time.
Named after Roman deities, the 8 planets of our solar system are remarkable sights to see, whether you're an amateur astronomer or an expert. Mercury, the Romans' messenger god, and Venus, the goddess of love, have phases just like our moon. Since Mercury's orbit hugs close to the Sun, it is best observed either before sunrise or shortly after sunset. Venus is the brightest planet in the sky, outshining many stars. Despite its visibility, observers are unable to see any surface detail on Venus due to the soup-like cloud covering that blankets the planet. Named after the god of war, Mars is one of the simplest planets to spot because of its brilliant red hue. The most noticeable features on Mars are its polar ice caps, which are bright white, and Syrtis Major, which is one of the darkest and most massive volcanic features on the planet. Jupiter is the largest planet in our solar system, and its amber hue glows in our night sky. Named after the king of gods, Jupiter has 2 main belt systems of swirling clouds that are visible with a small telescope, one in the north and one in the south. The Great Red Spot can also be seen along the southern edge of the south equatorial belt. Saturn, the god of agriculture, is visible to the naked eye. But in order to see its ring system, you must observe the planet with a telescope that has a 40 power eyepiece. Uranus and Neptune are much harder to find than the rest of the planets. Uranus, the god of the heavens, has a slight green tint, and Neptune, the god of the sea, has a blue hue. They can be seen using binoculars. Because of its great distance from the Sun, dwarf planet Pluto takes its name from the god of the underworld. A 12-inch telescope is needed to see it, but even then, Pluto looks like a tiny star. Our night sky is filled with billions of glistening stars. These distant diamonds sparkle with pacifying ambience. But through a telescope, we can see that stars are anything but uniform. They can be as small as 1/10 the mass of our Sun, or 40 times as massive. The most massive stars live for about 1 million years, and the smallest have lifespans that can exceed 1 trillion years. With such long life expectancies, is it possible to see a star die in our lifetime? How can we tell when a star takes its final breath? One clue to the age of a star is its color, and color relates directly to temperature. The hottest stars in the universe are called blue giants, followed by white and yellow stars. Blue giants burn out so quickly that they never have a chance to get old. Another way to get a sense of a star's age is its size. Stars like our Sun expand to thousands of times their size as they die, cooling and turning red in the process. One of the largest red giants, Betelgeuse, in the constellation Orion, is visible to the naked eye. Among the most interesting formations to observe in the night sky are binary star systems. Binary, or double stars, possess intriguing color schemes. Albireo, located in the constellation Cygnus, is a binary system in which one star is yellow-gold and its companion star is blue. With the help of an amateur telescope or binoculars, their contrasting colors are clearly discernible. If an aging star is about 1.5 times as massive as the Sun, it will die in an explosion, becoming a supernova. In most galaxies, supernovae appear once every 30 years, and in our galaxy, they are difficult to observe because most stars are blanketed by a heavy layer of gas and dust. However, if you are fortunate enough to see one, it will be an event that you will remember for the rest of your life.